This is a loosely coupled show with James Hickey and Comartin. If you're new to this channel, we chat about software architecture and design. Make sure to subscribe to get all our latest episodes.
Yeah, so Udi Dahan in his course, Advanced Distributed something, like Advanced Distributed Systems or whatever, he brings this chart up. And this relates back to what we were talking about, with like monoliths and kind of hosting, whether you should host everything in the same process, even if they're communicating via asynchronous messages. But I mean, this kind of scales out in terms of like processes and then actual machines. So it kind of goes more into the hardware aspects too. But I think the big point he was making here, if I remember correctly, in the course specifically, was comparing RPC versus like asynchronous messaging, and also talking about the aspect of logical coupling versus like physically decoupling things. So yeah, I mean, for me, looking at this chart, it's this chart is old. It says right there on the tweet, it's like 10 years old. So probably with like, I don't know. I know networks are much faster today than they probably were 10 years ago. And I've seen other tweets that actually were like, hey, sometimes you can actually get like more performance out of like these high bandwidth networks than certain kinds of disks. So it's, I guess it depends on like your hardware and where you're at. But I think for sure, like, just keeping this in mind as like this concept in mind, as far as like, as soon as you hit a network to do anything, really, like the performance cost is quite significant. And for most line of business apps, it probably doesn't matter that much. But definitely, even if you're looking at like caching, in this case, I'm going to consider in-memory caching versus like hitting a database, or even, let's say, hitting a cache that's on the network. I mean, you look at this chart and it's kind of like, yeah, like there's a huge difference there. So I think, yeah, it's interesting, because a lot of times we don't consider the performance impacts of kind of what we're doing, especially like we're just coding stuff up. Oh yeah, I'm just going to get this from the database, and I'm just going to get that from the database. And I mean, I've seen apps that, like right now, what I'm working on, there are some areas that are having performance issues that, need to be fixed sometime soon. And it really is that. It's just like people coming in and adding another database query, and then someone coming in adding another one, and then another one. And by the time 10 years rolls along, it's making like 20, 30 database calls, and it only needs like a small fraction of the data that it's getting. And some of the queries are like, give me this huge thing, and I only need this tiny little piece of that, right? So, I mean, performance, yeah, it's kind of it's a whole kind of other topic, but as far as architecture goes, it applies, because if you're, for example, using a cache, then you have to decide, like, am I going to cache things in a database? Like we had talked about before, maybe you can use like a separate table to kind of store post-transformed data, blobs, I guess, or JSON documents. Put it in a table. It's kind of like basically ends up becoming like a pre-computed view or projection. Or are you going to use Redis or something like that? Or is it beneficial to just do it in memory, because then you don't even have to go over the network, potentially? And then it depends whether you're hosting Redis local host, or if it's a service over another net, like those, it all impacts your performance, right? So I feel like that I see a lack in that area of each, like just even considering if I do this, what will the performance impact be? And comparing, if it takes you an extra hour to do something that's going to like affect the performance of it, like an important aspect of your application, if it's going to like half the performance just by taking an extra hour to whatever, right? Just to consider. To me, I think that would be important to do.
The thing that makes, when I see this, I think of, it goes back to our conversation prior to like the distributed big ball of mud, where you have, air quotes again, microservices that are communicating via RPC over the network. And this could happen in a monolith as well, if you're communicating kind of between boundaries in a monolith, even if it's in process, is when you make that network call. Let's say we're talking about services over the network, and you make it from service A to service B. You make a particular call because you need to get some information of some sort. You have zero clue what that service B has to then go do.
Yeah.
Right? And then let's say it needs to make 2 external calls to 2 other systems. Like, you're just compounding these problems over and like farther down the line, and it becomes more and more difficult to kind of trace these, where the actual issue lies, when we were again talking about debugging, but just in performance in general. Right? Now, again, this could happen even within a monolith. You could have this issue. You're going to have a hell of a lot easier time tracing all the calls that are getting made versus it being distributed. It's going to be way more difficult. But that's where I think it's like, okay, if you're in a monolith and you start splitting stuff up into services, stuff that was in process is no longer in process, and you just add latency.
Yeah.
So that's why I think it's just this compounding. So that's the first way I think of it. And then the second way I think of it, like of what you just mentioned, of like, hey, fixing a particular, spending that extra hour, I don't even think of it as like a per request thing that may be savings. I think of it just as this aggregate of the totality of the resources, right? How much load then you are reducing to whatever network calls you were making that you've reduced. And just the overall, so, you know what I mean? Like, and I've experienced this of spending some effort on kind of high traffic areas, or like stuff that we, processes that we run from messages that are easily the most frequent messages that we receive, and narrowing that hotspot down to it be as performant as it can, and how much that just reduces on the overall system as a whole.
Yeah.
So, because this isn't the right word, but it's like death by 1,000 paper cuts, right? Like, if you have all these little calls all like littered all over the place, you're like, oh, it's not that big of a deal. But once you multiply that by the number of requests that you get to that thing, it all of a sudden becomes a big deal. Yeah. And it's hard to, that's what I think about like this page. It's like, and what Udi says is like, it's hard to calibrate your mind to equate like the latency in such a small fraction of time. Like, I can't comprehend a nanosecond, but I can comprehend like a second. I can comprehend a little bit less than that, maybe half a second I could probably in my head. But when you start compounding these things in all these calls that you're additionally adding, I don't know, as developers, as you're writing some of this stuff generally, that you can really get the gist of as a whole, and it actually running in production under the load that you expect, or that you get, what the effects are.
Yeah.
It's just making another database call. It's like, well, not really.
Yeah, and that's it. Then you have like individual pages making more calls than they need. So if you have one page that makes two extra database calls, like two more than it needs, but you're serving like 100,000 requests, whatever, per hour, or I don't know, right? It's like that's gonna be 2 times 100,000
Yep.
more per that hour, like overall. And so yeah, I mean, we can go into an actual thing that I had to fix like a couple of weeks ago. I tweeted about this, about a cache, hand-built cache, in-memory cache thing. It's, oh man, I'll spare you. I'm giving you the short version. But essentially, someone, this has been in the system for a long time, and there's some places in a certain part of the system that, for example, will do some reporting. So you need to loop through a list of users, for example. The way the code was written is in the loop, it will actually call a repository to fetch the user. So you have basically every time you're in the loop, it's going to go to the database. So that was one problem. So the fix was to cache the list of users, for X seconds. So then every time you go to this repository, it essentially is not making the database call, which it's kind of the same relationship that you were talking about, where if you have one service calling another, you don't understand what they're doing behind the covers. And that's a good thing. Like, that's encapsulation, and that's kind of what you want in terms of, I shouldn't have to know that service is going to be making 10 database calls. And that's kind of different because I think the point there is you should just use asynchronous messaging, so you don't even, like, you're totally decoupled in that case. And you're not, like you said, introducing RPC all the way down the line here. Anyways, I mean, that was kind of an interesting fix. But anyways, the way the cache was actually built was really, like, performance-wise, it was okay, I guess. And there was just some weird coding around, like, when you're going to lock. Basically, the way it was working, there were two locks. And it would basically, it's like a global lock. So anytime, any request at all for the whole system, for any account, any user, it would come into this, like, generic method to get a list of something from the database. And it would lock, like, right away, lock everyone out of the system, and then, check, is it in the cache or whatever. So anyways, it's just a whole thing that I had to deal with there. But anyways, so I fixed that. I removed the locks and just kind of made it work the way you'd think the cache would work. But originally the issue was we had kind of this live production outage, and it wasn't like abnormal traffic. It was kind of, I'd say, pretty normal traffic, but definitely during the peak times of the day. And what was happening is, we do have a performance profiler that we use, which is really good. So plug for that. If you don't have any profiling or, like, logging in a production, it really helps a lot. Like,
Pretty
it
much.
can save you, like, weeks of trying to, like, duplicate issues and things like that, right? So anyways, yeah, we found a certain pattern. What was happening was database calls were happening really quickly, but then the actual, like, .NET application code itself was taking forever, like, super long. Requests were taking, like, a minute, right? Like, really bad, like, really simple requests that should take milliseconds for, like, a minute. People using the site weren't able to use it for the most part. Anyways, it was because of this locking, right? So the locks were trying to lock users out, and then again, in some cases, there's actually, like, two levels of locks, and then the way the actual approach to caching was wrong. So it was, like, the bad way of caching things. So it's like, I'm going to cache every single thing for this one account in one cache key. So if you just need to get, like, one user from a cache, you would have to get the entire cache for the whole account which means like, okay, if another account in the system wanted to put their data in there, it might evict another account's like entire cache. So it's just this like, right? It's like, I'm coming in and I'm going to blow your cache away. And a bunch of people are locked waiting, a bunch of threads. And then the next one from another account would come in and evict everyone else's cache because, yeah, anyways. Interesting. But it comes back to performance. Like that was never caught. Right. So it was just kind of a really wonky, must have been like a wonky race condition of some kind, right? It was just threads coming in at the right amount at the right time in the right order that they just, happen to be locking at the right order and people trying to cache the right things, to make the problem happen. So yeah, I mean, those kinds of things definitely like comes back to making the right fix for sure. But handwriting your own cache, probably not a good idea.
Yeah, I've been there. Well, not writing my own cache, but having cache issues itself. But yeah.
Yeah. But yeah, those kinds of things are fun. But if it's like coming back to this whole performance thing, if you can take the extra hour to kind of think about what this will affect or just how performant it will be.
Yeah.
That would make a big difference. And again, there's like, yeah, anytime you need to use like locks in your code or semaphores, I feel like,
what's going on?
yeah, like, should you?
Yeah, should you be?
Yeah. And I mean, I have another story around that kind of stuff, but if you want, I can share it or not.
Fire away.
Yeah, basically basically all the emailing is done through SQL Server, DB, send mail or whatever. It's like a procedure in there that can send emails from your database, which you shouldn't do, but legacy apps, some of them do that. So basically, I'm building a service, like a Windows service or an external process that now we're going to queue emails up just in a table, queue emails up, and then have this other process that'll just spin through those records and send the mail out. So that, I mean, huge performance gains just in not using the database to send via SMTP, which is shouldn't do that really, generally speaking. Definitely at the scale that this system has. But yeah, it's interesting. Like I had, on the topic of like concurrency, I originally written it so it would send emails in parallel. So anyways, long story short, yeah, I tested different configurations, like should I use 3, 5, 10 threads just to test what was more performant. I basically just settled for using like one, just going async await and not even dealing with any of that stuff, because the performance gains of actually like parallelizing that in terms of like the SMTP server that we have, I think it's the limitation of that server. It actually doesn't accept that. It doesn't handle like multiple connections very well. But yeah, I mean, the performance of just doing async await in .NET Core to do network, to do like I/O stuff, it's still very fast. Like the benefits of actually parallelizing that, in this case, I think we're restricted by the server we're connecting to. But yeah, I was actually surprised at how fast just one thread zipping through would actually work. I mean, basically, when you negate the I/O, like the actual application code, this is kind of weird. At one point, it was actually running too fast for the database, so it was actually getting like weird transaction issues, which I've never seen before, and that's kind of like an area I need to investigate. But it was kind of weird. There was kind of another fix to that, but it was kind of weird. Yeah, it was actually like running too fast and causing some like weird like I don't know. It was like too many transactions at once or something like that. Like it was strange.
We do kind of run not into that, but just in general, having some work that needs to be done. There's some number of iterations that need to occur, and whether we'd be better off taking that chunk of work and doing it as one kind of execution, or splitting those things up into individual units that would then get queued separately.
Yeah.
And the problem with it, there's kind of two issues. One is if we don't do it as separate units and something fails halfway through, it's that entire job needs to get redone. So then when you do that, you need to be aware of, okay, well, do I then have to look up within that individual job, say there's 100 things that have to get done. Do you know where it failed? Do you know that you don't need to redo those 50 things that, however many worked at the first before it actually failed? So that's always usually our kind of thing, is like, okay, well, do you want these things to be independently retriable if there's a failure in them? But then on the other side of that is if we make these things independent and they end up becoming just separate messages that get processed, is depending on how many there are, you're just out of nowhere spiking, not spiking, but depending on how many it is, we're all of a sudden increasing the number of messages that need to be processed greatly all of a sudden.
Yeah.
So, and then again, how does your system scale? Like, can it react to those increased number of messages that all of a sudden just came in? Like if it's significant, and we run into this, like, I don't want to say a lot, but it's always one of those kind of situations where when we're doing code reviews, it's like, do you want this to be one thing or do you want this to be a lot of things? Right? Because it's one job versus like thousands. Like do you want to chunk these things? Like how do you want to actually deal with processing them? Yeah. So it's an interesting problem anyways.
Maybe somebody should make a framework for that.
Well, that's the thing, is that there really isn't, because it's literally how do you want to deal with, like, kind of what I was alluding to, like, do these things can they be independently, do you want them to be independently retriable? Like if the whole thing fails, is it okay that you reprocess the whole thing again? If it's not, and you're going to make it one single unit, then you need to be aware of, okay, when it's reentrant, is it going to try to figure out where it was, or make those independent things idempotent? Like there's a whole whack load of issues there. Yeah,
those are some hard issues. I mean, what comes to mind is something like end service bus and sagas would probably be helpful, but again, like you have to know, like you're saying, even if you're using a saga, like a framework to help you with the infrastructure, you still have to know if you fail at point D, then you have to go back to point B or start over again, or maybe just keep retrying D. But then part E, if that fails, yes, you do have to go back to the start. So, and then you have to like emit messages to like undo the other things. Yeah, it can become pretty complicated. Yeah. If you're doing that.
We hope you enjoyed this episode of the Loosely Coupled Show. If you did, please subscribe for more on software architecture and design.